Hello everyone, my name is Marahim Hamid and welcome to this session where I'll be explaining elementary programming. Let's talk about identifiers. So what is an identifier? It is basically a sequence of characters that is consistent of letters, digits, underscores, and a dollar sign. So an identifier is where you actually come and declare a variable. There are many different types of variables and you need to name them so you can actually refer back to them. So you can either write a letter, which is a character, or a sequence of characters, which is actually a word that actually identify that data type. You can use as well as digits, underscores, and dollar signs. You cannot be using a number or a digit. So make sure about that. And you can't also use words that are reserved in Java. So there are some words that are actually identified by Java itself. You can't take it from there because they are already identified. So there are some words like true, false, or null. They can't be identified. You can't use them to identify something. So let's talk now about a variable or declaring a variable. In the beginning, you need to write your data type, which is in this case int, double, and char. We're going to learn more about these variables. And then you're going to take this, which is your identifier or variable. So here it's a character, as well as in here. And here it is a sequence of characters. Here x is the identifier, radius is the identifier, and a is the identifier. So you identify your data type using that in order to declare a variable. So in the beginning, you always need to write your data type and then declare your variable or write your identifier. Let's see this example here. For example, we have the data type double declared as radius. So radius is equal to 1. So double radius is equal to 1. And here you have the area. So double area. Here is our data type, and this is our declaration. This is our identifier. It says that the area is equal to radius by radius, which is 1. So 1 multiplied by 1 by 3.14,159. So that is the declaration of a variable. You tell what something is equal to, and then each time you declare it, it means it's equal to that thing. So when you go and print, we've talked about the printing statement during our last session. You're going to print the area is, and notice that it is between two quotation marks plus area. So here it's not between quotation marks because it's an identifier, and this is the area, so it's going to add this product of this mathematical equation plus then we have another quotations for radius, so it will be printed as it is, and then plus radius, which is not between quotations, so it's the identifier, which is 1. Here we have radius is equal to 2. We can use radius multiple times because it is defined in the beginning, so we cannot make a declaration on the same name of the variable for multiple times, but you can define it. Here we have radius is equal to 2, so area is equal to radius, which is 2, multiplied by 2, and then 3.14,159. And then the same what was going there in the printing statement is here. And there is one extra note. Here we have double radius and then a semicolon and then double radius is equal to 1. You can just simplify all that in one statement and say double radius is equal to 1 instead of writing this. Let's talk now about assignments. What is an assignment in Java? Assignment means equality. So instead of saying equal to, you say it's an assignment. An assignment is putting a value in a variable, and it's called also initialization. For example, here we have x is equal to 1. radius is equal to 1. A is equal to the character A. This is an assignment. It's just an equality and saying that that variable is equal to that value. Let's talk now about naming conventions. So when we need to choose a name, we need to have something with a meaning. So use something meaningful and descriptive when you actually declare a variable. Now, when you do a program, it's most likely that you will need sometimes to share it with some other peers. Maybe they need to develop that program, take a look at it, or maybe if it's in a work environment, your boss needs to check on it. So of course you're not going to make a variable with a vague name or maybe a silly name. You need to name it something that is related to what is going on in your program or something meaningful and descriptive of what's in that program. And in a program, you can't use more than one word. It's only one word. So you use lowercase letters, and if there is more than one word, then you capitalize the first letter of that second word. For example, if you want to write the area of a rectangle, you're going to write area and make sure that the first word of that declaration is in a lowercase, and then the second word needs to be capitalized of, and then again the third word needs to be capitalized rectangle. There isn't any spaces in the step of declaration. You just start by making the next word capitalized so we can actually identify it. Let's talk about the class names. In a class name, the first word always needs to be capitalized. So here when we said the area of a rectangle, the first was not capitalized, but in here we need to have the first word capitalized, the second capitalized, all of them needs to be capitalized. We need to capitalize all letters and consonants and use underscores to connect words. Now let's talk about numerical data types. They are extremely crucial and you will use them in every single program you do. So data types divides into two sections. The first is numerical and the other isn't. So in numerical data types, it's self-explanatory. It's for numbers. Numbers only. So you can't define a word or a list of characters or maybe even one character. You can't use a numerical data type for it. But you can define numbers, of course. So for the numerical data types, there is byte, short, int, long, float, and double. So a byte is the smallest, and then double is the biggest. We've talked about byte before, I believe, in the second lecture. We've said that 1 byte is equal to 8 bits, and short is equal to 16 bits. Integers are equal to 32 bits. Long is equal to 64 bits. Long is equal to 32 bits. And double is equal to 64 bits. Byte, short, int, and long are used for whole numbers, so numbers that doesn't have any decimal values, while float and double is used for numbers that contains decimal values. When you actually want to write that value in your program, what you actually are going to do is to write, for example, int, referring to integers, and then you're going to declare that variable. For example, let's say x is equal to 1, and then a semicolon. So x is equal to 1. And you need to declare that data type or add it in the beginning before x. So now we know that x is an integer and x is equal to 1. Say for example y is equal to 1, and then you need to write 0.0 because it's a decimal value. And that rule only also goes to float. When you come and declare a float value, you need to write float and then declare it. For example, let's say z is equal to a certain number, let's say 2, you need to do the same decimal value rule, and in float, what's unique about it is that you need to add f after the number, and then a semicolon. And the same goes to long, short, and byte. Now let's talk about double and float. So the double value is more accurate than float, and in some programs or in some occasions you can't use float because it's simply inaccurate and there will be an error in your program because you're using float. Having all these different data types is to have space. So when you write a very huge program and you don't really have that much of a space, you try to use all of these so you can use as much space as possible. Now let's talk about numeric operators. You have addition, subtraction, multiplication, division, and remainders. Make sure to always write your multiplication sign as this and your division signs like that. And how to calculate your remainder. And when you come and calculate your remainder, for example, let's say 20 divided by 3. For example, here it's going to be 6, and then subtract 18, and 2 here is the remainder. So sometimes you need to calculate the remainder in some programs. So you need to calculate the remainder by writing 20, and then we need the remainder of it when you divide it by, for example, 3, and see what it is equal to. Integer division. When you come and divide 5 and 2, you are going to have a remainder which is a double value. So you can't use an integer. Here is an example of a remainder operator. So in the beginning, of course, you always are going to follow the order of operation. So it's parentheses, exponent, multiplication, division, addition, and subtraction, all gathered in the word PEMDAS. So in the beginning, you're going to add 6 and 10, which is 16, and then calculate the remainder, and then the answer will be 2, which is the remainder of it. Now let's talk about augmented assignment operators. As we mentioned earlier, assignments means equality. So sometimes you need to use addition assignment, subtraction assignment, multiplication assignment, division assignment, and a remainder assignment. And for example, when we say I, then our addition assignment 8, it means that it's 1 plus 8, which is 9. Same goes for example, 1 minus equal 8, which is the subtraction argument. Sometimes the letter I is declared. So sometimes I might say that I is equal to 2 and I plus equal 8 is equal to what? So it's going to be 2 plus 8 equals 10. In some cases it's that, and other cases it's not. Because sometimes, in some cases, in some situations, in some places, I isn't declared and I is equal to 1 in that case. And I is a special character in that case. Now let's talk about an increment and decrement operators. What is an increment and what is a decrement? An increment means that you actually are adding. A decrement means that you are decreasing. So there is a pre-increment and there is a post-increment. When it's a pre-increment, then you are going to add before doing anything to that value. But a post-increment means you're going to do whatever mathematical equation is there and then do the addition for that value. The same for a pre-decrement and a post-decrement. In a pre-decrement, you're going to decrease the value before doing any operations, but in a post-decrement, you're going to do whatever you need to do and then decrease the value. Here we have an example. Let's talk now about the numeric type conversion. Sometimes you do declare some variables in a program, for example with a byte or a long, which is less than a double. And then, for example, here, as you can see, 100 is a whole number, and here this is all whole numbers in this equation. So there isn't any doubles really. But then, when you come and declare I, it and k, it is a decimal value. So how is that converted? It is automatically converted to the bigger value, which is a double. So there isn't anything to worry about. But you can't do the opposite. You can't have the double sized down to, for example, byte, long, int, or whatever it is. You can convert from small to big, but not big to small. If the conversion was from big to small, some of the data will be lost, so you need to be careful about that. Here are the conversion rules. If you'd like, you can stop and take a read of them. Now let's talk about casting. For example, in here we have a double D is equal to 3. Now we've talked earlier that when we write 3, we do write it this way because it's double, but here we have it as an integer. Now we all know that an integer is smaller than a double, so what will happen here? It will be automatically casted to a double, so it's fine if you wrote a 3 that way in your program because it will be automatically converted, and that conversion is called casting. But here we have an integer that is 5 divided by 2. Now, let alone that when we divide, we will have decimal points and there will be remainders, and that remainders is a double. But here also, when we write 2 this way, it means it's a double. And a double is bigger than an integer, so you can't really go back because some of the data will be lost. So here there will be an error in your program and your program will not run. Why? Because we have here the number 2 written as a double, which is wrong. You need to write it without the decimal point, and when you do run the program, and even if you do write it like this, you will still not have all the decimal points. Here are all the data type written from the smallest till the biggest. Here we have an exercise. Write 2 digits after a decimal point. So, for example, if we have a division and the output has many decimal points and we only want 2 of them. So that is also a job for casting. We will be casting those decimal points. Now let's talk about an exponent operation. So when we normally write an exponent, for example, 2 to the power of 3, we write it that way. There are many mathematical operations that we can pick and choose to write and do. We'll be learning soon as well in a different lecture. But now we're learning about the exponents. So we're having the word pow written. So power, and then we're writing this number in here, and then your exponent, which is 3, and that is all. And if you want to print it, you do write system.out.println, and then between 2 parentheses without quotations, math.pow, and then the number with its exponent. In Java, you don't write quotation marks when we want something to be done. When we want something printed as it is, we do use a quotation mark, but if there's something that is already identified in Java, whether if it's an equation, addition, or whatever it is, something that can be done, then you don't add a quotation. Now let's talk about number literals. They are a consonant value that appears directly in a program. And here are some examples of it. So here our literals are 34, 1,000,000, and 5. What are scientific notions? Here, for example, E means 10 in Java. So this E in here means to the power of 10 and represents the exponent. It can be written either in lowercase or in uppercase. Now let's talk about the arithmetic expressions, which is basically the orders of operation. All mathematical equations in Java needs to be written in the orders of operation. So as we mentioned previously, it's all gathered in the word PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. And if we want to translate this mathematical equation to Java, first of all, it's crucial to use parentheses. So in the beginning, you're going to add 3 plus 4x and then divide it to 5. This is now interpreted here. Now, why add these parentheses? Because if we didn't add them, it will only divide 4x and 5, not the whole thing. So you need to be careful about that point. Then subtract 10 multiplied by y minus 5, and then multiply it to a plus b plus c, divided to x, then add 9, finally multiply 9 to 4 divided by x, and then add it to 9 plus x. Here we do have 2 digits, so we do need to use parentheses. Divided to y, and then close this parenthesis, which contains all what needs to be multiplied by 9. And then when the compiler come and actually solve this equation, it will use the order of operations. So that's why when we come and write an equation, it's extremely crucial and significant for us to write it in a good order, or in the right order. Now let's talk about some common errors. Here we do have it declared wrongly. Here we have our identifier declared wrong. So in the beginning here we have the R capitalized, but in the second time not. So it's probably not the same thing. We need to have them both the same. Next in here there will be a logic error because the value will be having this output and it's incorrect because there is an integer overflow. Thirdly, we have this, which is the answer or the output of that question will not actually be exact, which is a round off error. Fourth and lastly is this error, which is there's all integers and the answer will be 1.5. Thank you for watching this video. I hope you enjoyed it. Please, if you have any questions, comment them down below.